Hey everyone, today we're going to discuss about the laws of logarithm. So we use the laws of logarithm whenever we perform operations involving logarithmic expressions. Now, there are three laws of logarithm. The first is the logarithm of a product, the second is the logarithm of a quotient, and the third is the logarithm of a power. The first one, the logarithm of a product, it states that the logarithm of xy to the base b is equal to logarithm of x to the base b plus logarithm of y to the base b. This means that if your argument can be separated into two factors, we can separate them, and vice versa. For example, if we have log of 15, note that 15 is 3 times 5. So log of 15 can be separated as log of 3 plus log of 5. In the same manner, if we have the expression log of 2 plus log of 8, we can combine these two together. It will become log of 2 times 8, which is equal to log of 16. So that's the first law of logarithm, the logarithm of a product. The second law is the logarithm of a quotient. This states that the logarithm of x over y to the base b is equal to logarithm of x to the base b minus logarithm of y to the base b. So if we have two numbers separated by a division in your argument, then we can separate the two logarithmic expressions together with the subtraction sign. So log of x over y to the base b is separated as log of x to the base b minus log of y to the base b. This works especially well when we deal with fractions. For example, if we have the logarithm of 1/2, this can be separated as logarithm of 1 minus logarithm of 2. In the same manner, we can combine two things together if they're separated by subtraction. Let's say ln of 5 minus ln of e. This is equal to ln of 5 over e. So that's the logarithm of a quotient. For the third law of logarithm, we have the logarithm of a power. This states that the logarithm of x raised to n to the base b is equal to n logarithm of x to the base b. So this means that if we have an argument who's a perfect n power, so we see the exponent here, n, we can just move the exponent towards the coefficient. So log of x raised to n to the base b becomes n times log of x to the base b. So we can just drop the exponent and put it as a coefficient. That's the logarithm of a power. For example, if we have logarithm of x raised to the 5th power, this we can take the 5 here, put it on the coefficient. So this becomes 5 logarithm of x. So that is the logarithm of a power. By the way, conversely, we can do the same thing, like 3 ln of 5. This, we can take the coefficient and put it on the argument. So this becomes ln of 5 cube, which is equal to ln of 125. Okay, let's have an example here. We have log of 2 plus log of x minus 4 log of e. So let's compress this expression into a single logarithmic expression. So we will be applying the different laws of logarithm so that we can combine all of them together. One thing that we can check here is that we have to check first if there is a coefficient in the logarithmic expression, because we'll be using the logarithm of a power for those expressions. So I would recommend you to start with the logarithm of a power. Then after if apply the logarithm of a power to those expressions applicable with that law, we will then apply the logarithm of a product and quotient. So as we can see here, we have a term here for logarithm of e. It has a coefficient of 4, so we can apply the logarithm of a power here. We can take the 4 and put it as an exponent of the argument. So we will not touch the logarithm of 2 plus logarithm of x yet. We'll just write it down here as logarithm of 2 plus logarithm of x minus, let's apply the logarithm of a power to 4. So this becomes logarithm of e raised to the 4th power. The coefficient becomes the exponent of the argument. So that's the logarithm of a power. Now, since there's no more coefficient, the coefficient is technically 1 or negative 1 here. Let's now apply the logarithm of a product and a quotient. So let's start with the first two. We have logarithm of 2 plus logarithm of x. Let's start with these first two terms. There. Since we have logarithm of 2 plus logarithm of x, addition here, so we will be applying the logarithm of a product. So we combine the 2 and x together, it becomes 2x. So logarithm of 2x minus logarithm of e raised to the 4th power. So we have this expression now. So let's take a look at this sign here. It's subtraction. So logarithm of 2x minus logarithm of e raised to the 4th power. So in this scenario, we will be applying the logarithm of a quotient. So 2x divided by e raised to the 4th power. So the expression will now become logarithm of 2x over e raised to the 4th power. So we're able to express this entire logarithmic expression into a single logarithmic term. So that's how we use the laws of logarithm. And it has some other applications in our next video, which is solving logarithmic and exponential equations. So I hope you guys learned a lot today, and see you guys in the next video.